The Build Show today, we are at a university that's designed for teaching builders. This is the BCIT, British Columbia Institute of Technology, and we're at the High Performance Building Lab, and I've got with me Alex, one of the professors here. Alex, you're more than a professor. You do everything around here, it sounds like.
A little bit of everything.
So tell me about this High Performance Building Lab we're in here.
So you're in one of our most unique classroom. It's a classroom where we do lectures around building science and workshops around construction. So in one space we talk about air tightness, we talk about heat movement, we talk about condensation and moisture. And as soon as we get the science, we turn around and we go and grab a hammer, grab a membrane, and we do it.
Man, that's cool, Alex. Now, in Canada, which is a little different than the U.S., in the States, we have some licensed trades, right? We have plumbers and electricians that need to be licensed, but carpenters don't need to be licensed. Builders, even in Texas, where I am, some states they do, builders don't need licensure. Tell me how that works in Canada.
So there are some similarities where if you work on what we call Part 9 construction, so single family or smaller residential, you don't necessarily have to have all the credentials to be on the site. But when you want to be a carpenter, typically the path you would take is you would come to a BCIT,
okay,
and you would probably come twice. You would most likely do your foundation program first.
Which is how long, a year?
So it's about a year,
okay.
And again, it depends on the programs, but roughly a year. And
that's post high school, right? So after you're finished with your high school.
That would be something you do when you're done with high school.
Okay.
I mean, our typical student might be straight from high school, might be a bit older.
Okay.
But they come here, they do their foundation, and then we'll see them again when they're ready to do their apprenticeship, where they have a sponsor, an employer out there that is already working with them.
Got it.
And then they come back and forth a few times, spending time with us.
And then at some point, are they taking a test and they're getting licensure as a carpenter in Canada?
Yeah, so eventually what you can do is get your Red Seal certification that
okay.
allows you to be recognized as such.
Gotcha. And that's true for builders, for electricians, for all the major trades and general contractors?
So most of the trades, and then for builders, there's a bit of a separate licensing system where there's a crown corporation called BC Housing that is making sure that builders are, aware of the code and the regulation, and they have to maintain their license through continuous education.
Right, so they've got to get like 20 hours a year or something of education?
Yes.
Gotcha.
And so that's done through, in BC anyway, that's done through BC Housing.
Got it.
And then what we do is we say, hey students, you've been at BCIT once or twice, maybe 5 years, 10 years, 20 years ago. Maybe things have changed. Maybe you haven't even discussed Passive House when you were here last time.
And you've got a whole course on Passive House, right?
And so we say, hey, come back and we'll just give you the upgrade you need. And it doesn't take long. The Passive House tradesperson course is a 5-day course. So
gotcha.
You come in on the Monday, you're done on the Friday.
That's awesome.
And really, we're adding to their knowledge. We're not starting from scratch. So it's in and out.
Give me a tour of the lab. This place is awesome, Alex.
So
where do we start?
We always kind of present it going from a bit of a clockwise rotation. So we have the classroom.
So start in the classroom.
And basically, if you were our instructor today, we would probably be set up with tables instead of chairs, because our typical class size is about 25 students.
Gotcha.
So each student will get a table, and you would be able to do a little bit of science with them using probably a PowerPoint or a more traditional mean of delivering your content. But very quickly, you would go from the classroom to what we call the workspace.
Man, look at these
where
awesome
you would
workspaces.
use some of the mock-ups. We call these guys our vestibules, so they're the smaller versions of the houses.
That's like a mini house, basically, right?
And you just get to apply what you just discussed using PowerPoints,
That's
right?
fantastic.
And so with the Passive House course, a lot of what we teach is around increasing level of air tightness, using high performance windows and increasing the effective R value, for example. So the students would install their membranes, they would learn how to do a transition for that air barrier to go from the outside to the inside, how to connect it with the window. And at the end, what we would do is we would put all these pieces together and get to a point where we'd do a blower door test on the work done by the students.
Is that right?
And
How
then they
about
would
that?
get to see,
How well they did.
How well they did.
Did they build it airtight or not?
Yeah.
Tell me about these mock-ups then, as these are part of classroom training, I'm assuming too, right?
So the mock-ups, we try to keep these mock-ups near the classroom, because what happens is the instructor will bring the drawings on the screen. So you'd have your 2D drawings you can use to, draw a red line that follows the air barrier, for example. But very quickly, the instructor could get the students to stand up and gather around the real thing.
Gotcha.
and get a feel for it.
So double stud construction.
Yeah, so always,
on the first one.
always in this space, it's always about increasing energy efficiency, which means that we're increasing the insulation level, which means the walls are getting thicker.
Yep.
And so version 1
So inside stud, outside stud. We're breaking with a thermal break.
I'm adding
No outside insulation.
No outside insulation, so I'm getting my effective R value through a pretty simple double wall in this case.
Yep.
And then if you move to the next wall here, we're saying, hey, maybe you can actually keep things the way they are most of the time in BC anyway, with a 2x6.
2x6 quote unquote standard construction.
Standard construction here.
Yep. And just like the States, Canada is a very lumber rich nation, so wood framing makes perfect sense for us.
It's a very natural thing for us to do.
Yep, for sure.
And so, how do you increase the R value of a single stud wall? You add
a couple inches of XPS on the outside would certainly do it. And I'm noticing everything around here is rain screened, and that's code, correct? To have a rain screen.
And so we've went through a phase where we learned quite a lot in a short period of time here around how to manage our water and our moisture. And one of the things we realize is we need to have a way to let the water out from behind the cladding. So everything comes with rain screen in Vancouver.
There's a famous guy that I like named David Nicastro who says it's not about keeping the water out, it's about letting the water out.
Exactly.
I love that. I love that saying.
And you're definitely a bit of an optimist if you think that you'll keep all the water out, right?
No.
So
you gotta let it out.
Plan for an exit somewhere.
And I see you have some good glazing here. This is an Inotech cutaway. I saw these guys being made yesterday. Nice triple glazing, set in a sill pan. Look at this, has even got a way for that water to weep out of there and behind the cladding, but in front of all the insulation. That's pretty cool detail. I like seeing that.
And so you also have, you can't see it on this one. Yeah,
insulated headers on this one as well. Insulation on the foundation. That's a nice mock-up. That really shows what you're talking about, doesn't it?
And what's interesting about this one is that we're actually using the XPS as our air barrier as well. So the XPS is taped at the joint.
Gotcha.
And transition to the inside through a bit of an interesting flashing detail here that transition to the top plate as well. And the last example would be probably the most common net zero energy / passive house building you would find in Vancouver these days.
A more common house wrap.
Common house wrap. So the WRB is acting as your air barrier
on the wall. So you're taping all this and caulking and doing the airtight layer
and it's transitioned as an air barrier through the top plate here. And then you're using in this case, your poly at the ceiling.
Okay, so this is actually the Tyvek's coming out over the top plate. And then you're using an adhesive on there. Is that looks like acoustic sealant too, which remains forever flexible.
Yeah.
And then it's being taped to the poly on the inside. Remember, this is cold climate, so we want to make sure that there's no vapor going from the house and driving through into the cavity to find a cold condensing surface.
Exactly.
So they've got a vapor barrier. And this detail I saw in that mock-up, I want to point that out again. That's really cool. These Inotech windows have a weep spot right here. And so they've got like a 3D fiber mesh right here, so that window, if it has a weep that comes out, it's going to go underneath here, but on top of the the cladding basically on the outside.
And
That's really cool.
What's great about this detail is that the mineral wool board insulation deals really well with water, so it's going to keep its R value even if it's wet.
Yep.
It's inorganic, so low risk of mold growth. But we're still trying to push as much as we can the water
To the outside.
So the flashing details here is again pushing with the blue skin, in this case, the water on the other side. But
Love
because the WRB is there, in the end, there could be water behind, and it would drain with the bottom flashing as well.
Yep.
So you still get your water out one way or another.
I like to see that you have a Texas brand here
Oh yeah,
at BCIT.
yeah, you're right.
The guys who founded this actually live in Austin.
Yeah.
And now they've sold. It's a bigger company. When I first moved to Texas, almost 15 years ago now, I had a cheap cooler.
Yeah.
And when I needed a new one, all the contractors in their trucks had these Yetis before they became popular. I went to buy one, it was like $400.
Yeah.
What?
Yeah.
$400 cooler?
Yeah.
But I'm guessing you're using this because of its performance value,
Well,
right?
we find similarities between the cooler analogy and the passive house or the high performance building. It's definitely worth paying a little bit more to save on how much ice you have to buy. So there might be a business case for that extra $100 because in a year you might buy $100 less of ice. But also, it's not just about money, but it's about quality. I like my beer cold.
Yeah, me too.
And there's no point for me to carry a cooler if the beer's not going to be cold. So we get the students to put some ice in the cooler and put their houses in and do all sorts of experiments.
Very cool.
Yeah.
My presentation I'm going to give here in a little bit too, we got like 30 or some students coming. I've got a couple slides on Yeti because I think their marketing is genius too.
Yes.
They really market high performance in a way that builders I think could learn from.
Yeah.
So we'll talk about that a little bit later.
So you and I later, we should have that discussion because I'm always amazed by how much we struggle in the construction industry at applying those marketing tools that others have mastered.
That's right, for sure.
And we're always talking about price all the time.
Yeah, how much more does it cost to do it that way?
But when the guy shops for a BMW or a Tesla, he's not talking about price first. He's asking about
Hyundai's a lot cheaper. Why don't I buy that?
Yeah.
No.
But it's the quality, it's the performance,
it's the durability,
it's
the resale value.
It's
all those things.
But
and there's a certain cachet for a better built product too, right?
Yeah.
And Yeti's cashed in on that. There's some lower priced versions of Yeti, but they don't sell for as much because they're not a Yeti. We're not sure if they're built as well.
Yeah. The analogy that I use when I teach one of our course here is I have this picture of friends gathering around a Mustang in Quebec, and they pop the hood, and everybody is gathering around the hood, and whatever they're looking at, everybody seems excited. There's something there. And I would love if we could get to a point where one day I invite you to my house, and as we come in, we pause in the doorway and we both look at the wall and like, whoa,
How about that?
That's a passive house, right? It's double stud. No, I went 8
inches of rock wool.
Because if you think of it, they're both marvels of engineering. They are better products, but one gets people excited and the other one, we're not there yet, right? And that's why I guess your show is a good thing because we are getting people excited with these things. So,
appreciate that. Now tell me about these displays back here.
So we have a few of we call them our science experiment modules. So these two modules are helping students understand heat transfer.
Okay.
So this guy here is a heating lamp.
So there's a heating lamp in the back.
And so we get the students to stand up,
feel the heat
break
from there.
Yeah, feel the heat. And when you put your hand here with the red light, you feel it right away.
Yeah.
And you can say, hey, radiation is a transfer of heat directly to the air, to a surface. I can actually block it with an opaque surface. It gets cold right away.
That's right.
Hot and cold.
As if you had a shade on the outside of your windows that came down.
And that's your shade. That could be a tree. It could be an overhang. Now, can I stop heat transfer through a transparent surface? Well, no, not if it doesn't come with low E coating.
That's right. So just clear glass, and hey, I can still feel the heat.
I can still feel the heat. There's actually no difference between my hand being this way and this way. And then we say to the student, well, push the last one. This one comes with low emissivity coating, and right away, you get almost 100% of the heat gets blocked. And instead
So
of,
that's the SHGC on the window label, right?
Yes.
Solar heat gain coefficient, and that coefficient is how much heat is it blocking. And
Yes.
so we saw some windows yesterday that had a 0.19, which means that 81% of the heat from the sun coming through that glass is blocked. So your hand's only getting 20% of the heat.
Exactly. And so
And
we
that's
can,
a great demo. Of that.
and you
I
get
love
it, right? You go
Yeah.
home and
So for
and we have
a
bit of
20-year-old
Yeah.
who hasn't thought about that,
Yeah.
that's a great
Exactly.
demo. And what's the conduction demo?
The
over
conduction
here?
demo is getting everybody to think about thermal bridging in this case. We have this little Peltier unit that is usually used in computers for cooling.
Okay.
So this surface gets really cold. We connected an aluminum bar, a regular carbon steel bar.
Okay. So aluminum, carbon steel,
And then stainless steel.
and stainless. Okay.
And stainless steel, if you look at their thermal conductivity property, this one doesn't conduct heat very well.
Right.
Carbon steel performs
Pretty
fairly
well.
well, but nothing compared to aluminum. So
Yeah.
you connect this gets cold. Within a few minutes, you put your finger here, it's as cold whether you're on the inside of the wall or the outside of the wall. But the stainless steel, after an hour, you might have lost half of a degree. But the students get to understand that.
Yeah, because you wouldn't make electrical wiring out of stainless steel, right? You'd make it out of aluminum or copper, which is very conductive.
You need a good conductor,
Yeah.
right? And so the debate here is, or the discussion with the student is, yeah, I have insulation and I have a wall, but if I have something going through my wall,
It's bridging through
it's
that
bridging
wall.
through that wall.
Yeah.
Yeah.
Now that other display had something similar to that, right? Over
Yes.
here?
So we work with a company called Shock to bring
Shock.
in
I don't know those guys.
a little freezer, I guess. So what
Okay.
you would
Ice cream freezer.
it's actually it's an ice cream freezer.
Yeah, I have one of these in my office.
Without the ice cream, maybe
Yeah.
we should bring the ice cream in
love
to
it.
get the students even more interested. So winter would be on the inside,
Okay.
and this would be inside your apartment or your house.
Now this one's freezing cold, and this one's pretty room temp. What's going on here?
So this one is a very standard concrete slab with very regular carbon steel rebars. So
Okay.
same carbon steel as the one we looked at together at the
Got
front
it.
there. And this one is thermally broken with a device that actually creates a separation between the concrete on the inside and the concrete on the outside. And the rebars are there, but they're made out of stainless steel, so bad thermal conductor.
Yeah.
Quite expensive,
Yep.
so you keep them short. And if you were to buy this, the carbon steel rebar would be full length.
And they figured out how to weld stainless to carbon.
And that's the secret here.
Because that's hard to do, I
Yeah.
think, right?
Yeah.
I'm no metallurgist, but
Yeah.
I understand you can't weld the two together normally.
So that's the special ingredient here, is to be able to do that connection and have the right structural properties.
So, like, if you're building let's say a balcony on a commercial building, you might use this to break your inside concrete from your outside concrete, but still have them structurally connected, right?
Exactly. So you could be walking, barefoot on your floor, and you wouldn't feel the cold.
And what's that? The similar?
Similar idea, but this one is to do a steel-to-steel connection. So you'd have a beam that needs to go through the wall.
Okay. To the outside.
To the outside.
And instead of having that continuous beam,
Which would be a terrible thermal bridge.
break it and put this in between and bolt it.
And so you have a foam separation, plus you have a stainless steel connection, and so you're separating the two
That's
thermally without separating them structurally.
I like it, Alex. Man, what a trip to BCIT. Very, very impressive facility. Man, they're putting out some incredible builders from this facility. I wish that we had more places like this in the States. If you're in Canada, I'll put a link to the description for these guys. If you're a high school student, you should definitely think about this. If you're in your 20s or 30s, you've been in the trades, but you want to change careers, check these guys out. I mean, this high performance building lab here, so cool. They're really teaching some good stuff here. Big thanks to my friends at Sega and Inotech and Quadlock for sponsoring this series of videos on the High Performance Vancouver Building Tour. If you're not currently a subscriber, hit that subscribe button below. We've got new content every Tuesday and every Friday. Follow me on Twitter and Instagram. Otherwise, we'll see you next time on The Build Show.